Hello again, my friends. We are going to continue with the second lot sizing heuristic, which is going to be based on the economic order quantity approach. So here the idea is to release an order at a fixed quantity whenever we have a net requirement. So unlikely to the lot for lot approach, here we are going to release an order at fixed quantity, and even if we have a single unit of demand at a certain period or a large amount of demand in that period, the order quantity will be fixed, which means some of the inventory will be carried to the next periods to meet the future periods demands. So how do we determine this fixed quantity? Again, we are going to use the formulation that we have developed in the basic economic order quantity model. Now, remember, in the basic economic order quantity model, the economic order quantity was formulated as the square root of 2 times k times d divided by h, where k was representing the fixed ordering cost, d was representing the demand rate, and h was representing the unit inventory carrying cost. Now here we do not have the demand rate because the demand is changing dynamically from period to period, but we have the original problem as it is mentioned here. In the original problem, we have the demand which changes dynamically from period to period in the following 10 weeks. So we can easily calculate the average demand per period by summing up all these demands for the 10 weeks. And after summing those up, we divide it to the total number of periods in our problem. Here, the summation for this problem is going to be equal to 270, as you can see. And when we divide it to the number of weeks, the average demand per period, or the average weekly demand, will be 27 units per week. Now, after calculating the average demand per period, we are going to use that average demand as the demand rate in the economic order quantity formulation. Here, K will be the fixed ordering cost in every period, and H will be the unit carrying cost, which is basically associated with carrying a single unit from one period to another. So we are going to evaluate our order quantity in the lot sizing heuristic with economic order quantity based on this formulation. And whenever we have a net requirement, we are going to release such an order. Okay, let's perform this for the same question, which we have mentioned when we were talking about the lot for lot approach. I'm not going to repeat the explanation of this question. If you have not watched my previous video about the lot for lot approach, please do so to learn about that problem. Now, in this problem, the demand for the following 10 weeks is listed as follows. Now, remember, even though we have 35 units of inventory in the beginning of the planning horizon, that does not mean we should exclude the demand amount of the first week when we are estimating the average weekly demand, because the larger size of data we use is better the estimate, you know. So we have 10 weeks of demand here. We use all of this information to estimate our weekly demand. Even if our initial inventory will be sufficient to meet the demand of the first week, it doesn't matter. We include that in this formulation. So 27 is the average weekly demand, and the fixed ordering cost is $100 in every period, even if we manufacture 1 unit or release an order of 1 unit or a large amount or large quantity. It doesn't matter. We always pay a fixed ordering cost of $100, and in order to carry 1 unit from 1 week to the next, we need to pay the unit carrying cost, which was mentioned as $1 per unit per week in the question. Now, when we plug in this information, K as 100, D bar as 27, and unit carrying cost as 1 in this formulation, the economic order quantity will be estimated as 73.48. Now, we are going to round this to the closest integer in this problem because we are solving this problem usually with discretized values, and the integers are the best candidates for the discretized values. Now, 73 units will be the approximation of our economic order quantity, which means whenever we release an order, so in order to release an order, there should be a net requirement. Whenever there's a net requirement, we release an order of 73 units. So we are going to apply it as follows. Now we know that in the first week, the demand will be met by the initial inventory of 35 units. So there will be no net requirement in the first week. The first net requirement will be observed in the second week as 30 units, okay? Because there will be no on-hand inventory carried from the first week to the next. And all of the demand will be creating a net requirement here of 30 units. Now that we have a net requirement, we are planning an order receipt of 73 units, which is our economic order quantity, exactly the second week. Now, these 73 units of inventory will meet the net requirement of the second week, which is 30 units. This means 43 units of inventory will be carried to the next period. And in the next period, the demand is 40 units, which will be met by the on-hand inventory, but 3 units will be carried to the next period, which is the fourth period. Well, in the fourth period, there is no demand. Therefore, these 3 units of inventory will be carried to the next period again. And in the fifth period, the demand is 10 units. But we have 3 units of on-hand inventory carried from the previous weeks, previous periods, which will create a 7 units of net requirement in the fifth week. Now that we have a net requirement, we need to plan an order received at a quantity of 73 units again in that period. Now, if we receive 73 units of inventory here, the net requirement of 7 units will be met, which means 66 units of inventory will be carried to the sixth period, and the demand in the sixth period is 40 units, which will be made by the 66 units, and the exceeding units will be carried to the next period as 26 units. However, the demand in the seventh week was 30 units. Therefore, this means there is also a 4 units of net requirement that will be observed in the seventh week. In order to meet that, we will again plan an order receipt of 73 units in the seventh week. That 73 units will meet the net requirement of 4 units, but this means 69 units of inventory will be carried to the next period, where we observe no demand, and to the next period we carry 69 units again. Here we have a 30 units of demand again, my friends, and that will be met by this 69 units, and the remaining 39 units will be carried to the next week, and in the next week we have 55 units of demand, which is not going to be met by the existing on-hand inventory, which means at this point we need to plan another order receipt, as we have a 16 units of net requirement. Now, when you plan a receipt of 73 units again here, it will meet 16 units of net requirement, and after that, the remaining 57 units will be carried to the next planning horizon, okay? Now, again, because we have a supply lead time of 1 week, in order to receive 73 units of inventory in the second, fifth, seventh, and 10th weeks, we need to release the regarding orders 1 week earlier. So in this schedule, my friends, we will be releasing 4 separate orders. For each of them, we need to pay a fixed ordering cost of $100. So the total ordering cost will be equal to 400 associated with this plan. Now, remember, we are going to pay the carrying costs associated with the on-hand inventory from second week to the 11th weeks, okay? So we are not considering this 35 units when we are calculating our inventory carrying cost, because this inventory is already carried from the previous planning horizon to this week, okay? Now, this cell shows us the inventory carried from the first to the second week. This cell shows us the inventory carried from the second to the third week, remember. So we are just going to consider the cells from the second week to the 11th week, and the summation of the carried inventory from one period to the next is equal to 375 here. Now, each unit that is carried to the next period costs $1. Therefore, the total inventory carrying cost associated with this schedule is 375. The summation of the inventory carrying cost and inventory ordering cost gives us the total inventory cost associated with this schedule, which is 775. As you can see, this cost is a little larger than the cost associated with the lot for lot heuristic. So sometimes, my friends, the lot sizing heuristic with economic order quantity does a lot worse than the simple fundamental lot for lot approach. Why? Why is the reason for that? So let us explain why this had happened. Now, my friends, the lot sizing heuristics based on the economic order quantity approach is rather effective in the demand profile where we have a stationary demand. Now, you see the demand amounts in this problem. They are changing so frequently and the oscillation magnitude is very large, okay? So sometimes we have stationary behavior in the following weeks, but then the demand suddenly decreases to zero, and that this happens twice in this planning horizon. So if the demand behavior is obviously dynamic, okay, we are dealing with dynamic demand profile here, but even if it is dynamic, it seems to be a little bit steady, which means it is oscillating, but around a certain level with a small amount of variance. In that case, lot sizing heuristic with the economic order quantity approach would yield beneficial results. Okay, most probably it will yield less cost than the lot for lot approach, but here, unfortunately, the dynamic behavior of the demand is so strong and the magnitude of the oscillations is so large. Therefore, we have seen worse results, unfortunately, compared to the lot for lot approach here. Okay. So please note that the lot sizing heuristic based on the economic order quantity approach is effective only if the dynamic demand behavior is showing only a small magnitude of oscillation between the consecutive periods of the planning horizon. Okay, we are going to deal with the periodic order quantity heuristic in the next video. Hope to see you there.